Hi friends, I am Amaresh. Today I am going to speak about AC and DC voltage and voltmeter, multimeter and clampmeter. So first I will start from AC voltage. What is AC voltage? The voltage which causes the alternating current is known as the AC voltage. The alternating current induces in the coil when the current carrying conductor rotates in the magnetic field. The conductor, when rotates, cuts the magnetic flux, and the variation of the flux induces the alternating voltage in the conductor. Okay, so when we come to like plus minus sine waves called AC voltage. So the voltage which causes the alternating current, okay, that we called AC voltage. And next I will go to DC voltage. I will explain DC. The DC voltage induces the direct current, okay, the waves only in one direction, and the magnitude of the voltage always remain constant. The generation of DC voltage is quite simple and easy. The voltage is induced by rotating the coil in the field of the magnet. The coil consists of the split ring and a commutator which converts the alternating voltage into direct voltage. Okay, so what is DC? DC just I explained, and key difference between AC and DC. The voltage which causes the alternating current is known as the alternating voltage. The DC voltage produces the direct current. The frequency of AC voltage depends on the country. Mostly 50 and 60 Hz are used. Varies the frequency of DC voltage becomes 0. In India standard we are using 50 Hz. Okay. The power factor for AC voltage lies between 0 to 1, and the power factor of DC voltage always remains 1. The polarity of the AC voltage always varies with time, and the polarity of the DC voltage always remains constant. The AC voltage is unidirectional and DC voltage is bidirectional. The generator generates the AC voltage, and the DC voltage is obtained from the cell or battery. The efficiency of AC voltage is high as compared to the DC voltage. The impedance is the passive parameter of the AC voltage, and for DC it is resistance. The impedance means the opposition offered by the voltage to the flow of charge. The AC voltage has amplitude, whereas the DC voltage does not have amplitude. The term amplitudes means the maximum distance covered by the oscillation and the vibration body. Okay, these are all the difference between AC and DC voltage. So now I'll how to measure this voltage. We need to check voltage. To measure we have a device like voltmeter or multimeter. Okay, so when we come to this voltmeter or multimeter, I will explain slight difference about voltmeter and multimeter. Volt is a unit of measure of the potential difference between two nodes. The voltmeter measures this difference and provides the results in volts. Some voltmeters are designed in a way so that they can work well with alternating current, with direct current, while others are capable of measuring both. Inside voltmeter, there is a current carrying fine wire coil. The coil gets suspended around the external magnetic field. Once that is done, you connect clamp or leads on the device to the power source that you wish to measure. In the next step, the current flows through the voltmeter. Then the current reacts with a magnetic field around the coil that begins to spin in response. The rotation leads to the needle moving along the analog meter, like analog voltmeter. and that is how you get to know what the voltage is. However, the digital voltmeter version functions slightly different. It is more resistant to outside magnetic interference and not a risky of damage. Then comes to the multimeter. Just like the voltmeter, you can record voltage with a multimeter, and it has the capability to measure ohms and amperes, the units of resistance and current respectively. The high-end units are also capable of measuring other things such as temperature, inductance, capacitance, frequency, relative humidity and acidity. A multimeter range varies from 200 millivolts to 2000 volts, which means that you can use them on a variety of common circuits with a great degree of accuracy. Furthermore, analog multimeters are called ohms, which stands for voltage, ohms, amperes. The newer digital models are often abbreviated DMM for user guessed it digital multimeter. This is because different measurements need different internal resistors to get accurate measurements. You might even find different external ports to which you must connect the test, as it helps in getting accurate reading. Okay. However, a multimeter might cost a bit more, and the prices increases with the number of things can measure and other important factor like current and voltage with which it can function. Also, a digital model can be more expensive than analog models, but you do not need the expensive ones for basic household tasks. So how to measure AC voltage in the sense, just there is a lead, positive, negative, that we can keep in the socket and we can check. Okay, this is the a slight explanation about this voltmeter and multimeter. Now I am going to explain you this clampmeter or ammeter. So what is clampmeter? First thing, what is a clampmeter? A clampmeter is an electrical testing tool that integrates a basic digital multimeter with a current sensor. Clamps measure current, probes measure voltage. The integration of a hinged jaw into an electrical meter enables technician to securely clamp around a wire, cable or conductor at any point in electrical system, facilitating current measurement in the circuit without the need for disconnection or de-energization. Beneath the plastic moldings, the hard gel consists of a ferrite iron and are engineered to detect, concentrate and measure the magnetic field generated by current as it flows through a conductor. This versatile tool facilitates the accurate measurement of electric current without direct contact or circuit interruption. Primarily through its clamping mechanism, it efficiently captures current readings while also providing the capability to measure voltage, resistance and sometimes even frequency, making it an indispensable instrument in electrical maintenance and troubleshooting. So I will tell you best clampmeter features. Originally designed for specific testing purposes, modern digital clampmeters now offer expanded measurement functions, increased accuracy and in some cases specialized features. They encompass most basic function of digital multimeter, including voltage, continuity and resistance measurements. Notable clampmeter features include like current sensing jaw, tactical barrier for finger protection from shocks, hold button freezes the display reading, released with a second push button, dial also known as the rotary switch, display, backlight button, minimum maximum button, display maximum input on the push subsequent pushes, show minimum and average input in current, voltage and frequency modes. Inverse current button, 0 button, yellow, remove DC offset from DC current measurements, and serves as the dial shift button for selecting yellow functions. Jaw release lever, alignment marks, conductor alignment required to meet accurate specifications, common input jog, voltage home input jog, input for flexible current. So these are all the features is there in this clamp meter. So next, how to use this clamp meter? This is also most important, right? If you don't know how to use clamp meter, then it may be causes to some other accident and these things. Okay, so using a clamp meter effectively involves a combination of technical knowledge and practical skill. To start, ensure that the meter is set to the correct measurement type, current, voltage, resistance or others as needed. If you set wrong voltage, we can set it resistance, then maybe something problem. For current measurements, open the clamp by pressing the trigger and carefully circle one of the wires in a circuit without touching it directly. This allows for non-contact current measurement. For voltage or resistance tests, use the probes, inserting them into the appropriate ports on the meter. Always observe safety protocols, including turning off power before connecting probes and never exceeding the meter's rated measurement range. When measuring current, it's crucial to isolate the wire being tested to avoid inaccuracies from nearby wires. With a clamp securely around a single conductor, the meter will display the current flowing through it. For voltage measurements, touch the probes to the corresponding test points, one to the live wire and the other to a neutral or ground line. The meter screen will display the voltage level. Regular calibration and proper storage of the clamp meter are vital for maintaining its accuracy and longevity. Remember, understanding the specific features of your clamp meter model is key. A clamp meter model is key for its optimal use. So, and one more question: why use a clamp meter? Clamp meters have gained popularity for two main reasons. First is safety and convenience. Safety: clamp meters allow electrician to avoid the traditional method of cutting into a wire and inserting test leads for an inline current measurement. Convenience: there's no need to shut off the circuit carrying current during a measurement, significantly enhancing efficiency. Clamp meters are preferred for measuring high levels of current. Digital multimeters cannot measure 10 amps of current for more than 30 seconds without risking damage to the multimeter. These meters typically offer a minimum current range of 0 amps to 100 amps, with many models extending up to 600 amps to 999 amps or even 1400 amps. Some plug-in clamp accessories such as the iFlex can measure as high as 2500 amps. So, digital clamp meter applications. Digital clamp meter find application in various settings, including industrial equipment controls, residential, commercial, industrial electrical systems, and commercial industrial HVAC. They are preliminarily utilized for service, installation, and maintenance purposes, offering a valuable tool for system troubleshooting and scheduled preventive maintenance. So, different type of clamp meters. There are three main types of clamp meters exist: current transformer clampmeters measures only alternating current AC. All effect clampmeters measures both alternating current and direct current. So flexible clampmeter employ a Rogowski coil measuring AC only and are particularly useful for measuring in tight spaces. DC clampmeters are Hall effect clampmeters. Hall effect clampmeters can measure AC and DC current. The core of these meters lies in the unique construction featuring iron jaws that intensify the magnetic field around the conductor. They also use a Hall effect sensor that converts this field into electric signal. Okay, next key to their accuracy is the process of zeroing, which compensate for external magnetic influences, ensuring precise current measurement. Okay, so these are the details I tried to explain you about voltmeter, multimeter and clampmeter. So please like my video and subscribe my channel and support me for more videos like this. If you like or if you support, if you subscribe, then I will get some encouragement to do